Hello everyone! In my previous video, I built a voice chatbot with Google Gemini. I was able to run that code on Windows and Raspberry Pi. So when AI responds to my questions, it will pause in the middle and then continue after that. The reason for this was because that the code was sequential processing. Here's a diagram shows the process. So when we ask Gemini a question, we will get one piece of information from the reply first, and then we convert that into an audio file, and then we play that audio file. After that, we will check to see if the second part of the reply is available. If it is, and then we will do the same thing for the second one and the third one. The problem of this process is that once it finished playing the part 1, for part 2, it will need to do the text-to-speech conversion for part 2 before it plays the audio of part 2. So during this process, there is a pause. And in today's video, I'd like to show you a parallel processing method, which runs on multiple CPU cores. So what it does is that we distribute the tasks into 3 threads. Thread 1 for the processing with the large language model Gemini. And then process 2, we just do the text-to-speech conversion, and process 3, we will play the audio file. Of course, over here we have to coordinate so that we do the text-to-speech conversion after the part 1 of the reply is available. And then once we finish the text-to-speech conversion for part 1, and then we start playing the audio of part 1. So we have to be careful of this process. So before I get started about the code, I'd like to show you a live demonstration to see how it works. So this is a sequential processing. You can hear there's a pause in the middle of the reply from AI. Hi, Jack. What's the best way to get to San Francisco from San Diego?
Driving. Route. Take I-5 north for approximately 515 miles, 830 kilometers. Duration. Approximately 8 to 9 hours. Cost. Estimated $100. Minus $150 for gas and tolls. Flying. Direct flights. Southwest Airlines, Alaska Airlines, Delta Airlines, and United Airlines offer direct flights between San Diego International Airport, SAN, and San Francisco International Airport, SFO. Duration, approximately 1 hour 15.
Okay, that's the end of the sequential process. Now let's look at the parallel processing method. Hi, Jack. What's the best way to get to San Francisco from San Diego?
Driving. Distance, approximately 460 miles. Time, 7 to 8 hours, without stops. Route, take I-5 north. Cost, fuel, tolls, and parking, if applicable. Flying, flight time, 1 hour 15 minutes. Cost, varies depending on airline and time of year. Airlines, Southwest, United, American, Delta. Airports, San Diego International Airport, SAN, to San Francisco International.
As you can see from this demonstration, the parallel processing method is much better than the sequential process, because in the reply of the AI, there was almost no pause, no gap between the reply. And in the first one, we can hear there was a period of time, there was no voice from the AI. So let's see how can we build a system like this. I'm going to talk about the requirements. At first is the hardware. We need a Raspberry Pi with a micro SD card, and we need a speaker and audio amplifier, microphone, and we also need a computer and LEDs if you do have LEDs and resistors. I have another version of this code which does not require LEDs and resistors if you want to go with that. You also need to install Python and additional packages, which I will list in the GitHub page. I will put a link to the GitHub page in the description below. So we also need a PuTTY and WinSCP to deal with the files between Windows computer and the Raspberry Pi. On the Windows computer itself, I use Visual Studio to write the code, and you can also use other programs. So you also need a Google Gemini API key if you don't have that. Please check my previous video. I talked about how you can get this and set it up. So the next thing is we have to set up the Raspberry Pi with all the hardware I talked about in the previous slide. And then I have two versions of the Python code. If you have LEDs and resistors, you can use the first version. Otherwise, you can use the second version. The second version works not only on Raspberry Pi, it also works on Windows 10, Windows 11, etc. Once you transfer the Python code on Raspberry Pi, then you can run the code and it will just take questions from the user and get a response from the AI. Now let's take a look at the code. So this is a version of the code which works on Raspberry Pi only because I have LEDs here. It's pretty much the similar as before, except I added the threading and queue and time packages over here. So please check my previous video. I talked more about the details of this code. And over here, I'm just going to highlight the difference added to this code. Same as before, I'm using pin 24 and 25 for the two LEDs, green and red. So we initialize the game package over here. We'll save the date of today in this variable today here to use that in the name of the log file. We define some variables to use with this module, and the most important variable here is the maximal output tokens here. I'm using 128. You can increase or decrease. According to the documentation, 100 tokens is corresponding to about 60 to 80 words. And over here, we start the chart with Gemini. And I define several functions to do all the tasks like text-to-speech conversion and play audio files and then save conversation to the log file. And we'll talk about those later. And today I want to start with the main function here. And in this main function, we start with the speech recognizer and then microphone here. We turn off the dynamic energy threshold and we instead define energy threshold of 400, which works pretty well in the quiet place. So I define a variable sleeping here. So the AI is going to be in the sleeping mode. We have to say a wake word to wake the computer up. So here is a while loop. So this loop is going to be running all the time. And at first, what we do is that we adjust the ambient noise. So at first, we turn on the green LED and print listening here, so which tells the user it's time to ask questions. And over here we record the question from the user and we convert that question into a text. After we get the question from the user, we turn off the green LED and then we check to see if the user said the word Jack. So Jack is the wake word. So if the user said that, that means the computer is going to be awake. And we turn off the sleeping variable here. So we start a new conversation here. If the question from the user here is too short, then we will ask the user to say the question again. Over here is the case when the AI is awake, which means if the user asks a first question and then now the user asks a second question. So if the second question is that's all, so that means end of the conversation. So the user has to wake up the computer again in order to speak with the AI. So if the user said Jack in the second sentence, so we will just remove that and then we will send the rest of the question to the AI for a response. So at this point, we should have a question from the user and we save the question into the log file and then we print the question back to the user so that the user knows what's going on. So at this point here, we're going to split the tasks into 3 threads. 3 CPUs are going to work together to process the reply from the AI. We define several variables here. This text queue here is going to save the replies from the AI. So once we get one part from AI, we save here. We get a second part, we save here. Same thing, once we convert a part 1 into audio, we save to this variable here. We convert a second part to audio, we save back to this variable here again. So this is a stop event over here. So what that does is we're going to monitor whether we finished everything, finished playing the audio, we finished doing the text-to-speech conversion. Once all is finished, we're going to turn this on so that all the process knows. And this variable here is to monitor the data from the text-to-speech conversion part. And this variable here is going to monitor whether the AI is finished responding to our questions. And the last one here is to monitor whether the audio is playing right now or not. So at this point here, we define 3 threads. And thread 1 is going to deal with the large language model Gemini. And thread 2 is going to do the text-to-speech conversion. And thread 3 is going to play the audios from the thread 2. So for each thread, we define a function. I will talk about the arguments of the functions later. Once that is ready, so we start the 3 threads together. So this is really the point where we split the process into 3 threads. And over here, I like to wait for the threads to do the work. So we have to wait a little bit for the AI to respond. This text queue here is to wait until we finish receiving the data from the AI. Once we finish the processing of the reply from AI, we turn this on so that we can continue and join the first thread. Again, for the text-to-speech conversion here, I like to wait a little bit, and once we finish processing the audio files, and we can set this stop event on here. So all the threads will quit and join together. So this is the point where we join 3 threads together at this point over here. So at the end, we just finish up like before. So, and then I'm going to talk about the 3 functions. So in this chat function, we send the question from the user to AI, and we wait for a response. So once we have a response from the AI, and then we print that out, and then we save this response into this text queue here. So this variable is shared variable between the thread 1 and the thread 2 here. In thread 2, we convert that response into audio file, and in thread 3, we play that audio file. So over here, I like to wait a little bit of time, for AI to get back to us for the second part of the reply, and part 2, part 3, etc. So, and once that finished, we save all the response from AI into our log file, and then we set this variable into true here so that all the threads know that the first thread is already finished. So in this second thread, we will convert the text from the AI into audio. So at first, we will wait a little bit for AI to respond. And over here, I define an event. So this is true only when we finish all the tasks, including plain audios, text-to-speech conversion. Once we have data in the text queue, we will get that text to this variable text over here. And if it's too short, then we will continue. This part here is probably optional. Then we allocate some space in the memory, and then we convert the part 1 of the reply into the audio file here. And then we save the audio file into the memory. And we put that audio file into our audio queue here. And over here, we define a waiting variable here, which equals to true. This while loop will start from here, and this basically now here is an event variable which tells thread 2 that thread 3 is playing audio right now. So in the beginning, this variable is going to be false. So in the beginning, the first time, and then we will go here, we will set data variable which tells thread 3 that thread 2 has audio file ready to play by thread 3. So then we turn off the waiting, and then we go back to the end of the while loop in thread 2. So once this data variable event is set, so which means thread 2 is telling thread 3 the audio file of part 1 is ready to play. So go ahead and play this audio file for the part 1. And then this part will go back to process the part 2 of the reply from the AI. Once the thread 2 is finished processing the part 2 of the reply from AI, then the audio file here will be saved into this queue here. And then we will check whether thread 3 is playing the audio file for part 1. If it's still playing, then the thread 2 will wait until it finished playing part 1. Once thread 3 finished playing the audio file, this will become false. And the thread 2 is going to continue here and tell thread 3, okay, the audio file for part 2 is available. So go ahead and play the audio file of part 2. So etc. This loop is going to work until the end of all the parts are finished processing. So in thread 3 here, what we do is to play the audio from the thread 2 here. So again, here we monitor the stop event. If the stop event is not set, that means we are going to keep running until the stop event is set. So once the audio file for the part 1 becomes available, we will clear this variable and start processing, and we will set this busy variable into true. So, and then we will get the audio from the audio queue, and then we go back to the beginning of the audio file. We turn on the red LED, and then we play the audio file over here, same as before. Once we finish playing the audio of part 1, so we clear this variable here, then this part becomes false. Then thread 2 is going to send thread 3 the audio file of part 2, and then we'll continue from there. Once we finish processing all the audio files, and we will break from here and quit the thread 3, and then we will set a stop event and then draw all the threads together here. So this part here is really the end of the parallel part of the program here. So that will be corresponding to this point over here. So I have 2 versions of this code, and this is for LED version, and this version here does not have LED. So I'm going to run this here as a live demonstration for today. Hi Jack, what's the name of the tallest building in the world?
Burj Khalifa.
How can I get there from San Francisco?
By plane. 1. Book a flight from San Francisco International Airport, SFO, to Dubai International Airport, DXB. 2. Upon arrival at DXB, take a taxi or ride-sharing service to the Burj Khalifa. The journey takes approximately 30 minutes. By public transportation. 1. Take the BART, Bay Area Rapid Transit, from San Francisco to the San Francisco International Airport, SFO. 2. From SFO, take a flight to Dubai International Airport, DXB. 3. Upon.
Continue.
By public transportation. 1. Take the BART, Bay Area Rapid Transit, from San Francisco to the San Francisco International Airport.
Okay, you get the idea, so this works really well. I'm going to upload both versions of the code to the GitHub page of this project. Please download the code and study the code offline to fully understand and how it works. I hope you learned something from today's video. Please check our GitHub page for the Python code and a detailed instruction on how to use it. Please leave your questions and suggestions in the comment section below. I will get back to you as soon as possible. Please subscribe our channel as I have more videos coming up about AI, large language models, IoT device, and robots. Again, I hope you enjoyed this video. See you next time. Bye bye.